Here we go. This is good for students who are looking to test out of Algebra 1 or to test into Honors Algebra 2. This is a comprehensive worksheet that goes over all of Algebra 1 concepts, and some of these Algebra 1 concepts are also in Algebra 2. So let's start with the first one, solving for the variable. You have variables on both sides, so we want to isolate all the variables on one side and the constants on the other. We can't do that until we simplify each of those sides. So the left side is already simplified. We can distribute this -8 into the parentheses. -8 times 3 is -24. -8 times 7 is -56x. We're always going to move the variables first. I'm going to move this variable just because it's smaller, but this will give me a negative variable. So you could have moved the -56 to the other side. And since I'm being efficient, I'm going to move my constants to the left side. So I can do two steps at once, making sure that I balance both sides. Left side will give me 50. Right side will give me -50x. Now I'm going to divide by -50, and I get -1 equals x. Oh, that's not good. Why didn't that do? That is very interesting that it would do that to me. That's going to make it a little bit more of a pain in the butt, but that's okay. Here we have absolute values. Absolute values we're going to treat like variables, only that the variable, instead of this being what we're going to isolate, we're actually going to isolate the entire absolute value. We're going to get the absolute value by itself. It's being multiplied by 6, and 9 is being added to it, so I'm going to get rid of things being added and subtracted first. We get 6 times the quantity times the absolute value of n minus 8 equals 63 minus 9 gives us 56. No. Not 56, hello, 54. Now we're going to divide by 6, and we get the absolute value of n minus 8 equals 9. Now that we've isolated the absolute value, we know that whatever value in here, what would produce the absolute value of what, if we covered that up and didn't see that n minus 8, and we just, let's cover it up. If we just saw this and we had this, what value could go in there to produce the absolute value would give us 9? Well, -9 and +9. -9 was for x, meaning if it was inside, it would produce that. So we have to separate this. N minus 8 gives us 9, and n minus 8 gives us -9, because that wants to be able to find out what, I did it again. This is going to be a pain in the butt. Let's work with it. I'm just moving my computer closer to the board so I can manipulate it. That's going to be somewhat tiresome, but we'll deal. So let's isolate n, +8. We get n equals 17, add 8. Add 8, we get n equals -1. So my two solutions are -1 and 17. If I plugged in 17 in here, that would give me +9. The absolute +9 is 9. If I plugged in -1, that would have given me -9. Absolute value of -9 gives me +9. So that's what I meant, that this piece, when I said that, right, it has to equal 9 or -9. So what value for n would make that 9 or -9? That's why we write these two statements. N minus 8 can equal 9, or n minus 8 can equal -9. Let's look at number 3. Now we're moving on to graphing. Sketch the graph of each line. This is in standard form. So when we're in standard form, we know that we get the x and y intercepts, and I'm going to cover the other one. So the x-intercept equals -3. I go on the x-axis, I make a dot at -3, and then I cover up the x, and -y equals -3. If I divide by -1, I get y equals 3. So my y-intercept is 3. The easiest way to graph that line is through those two intercepts, and very nice and efficient. Here we are in slope-intercept form. So we're able to find the slope, which is the coefficient of x, and the y-intercept, which is whatever is being added to that variable. So my slope is -1, that's the coefficient of x. My y-intercept is -1. It's going to cross the y-axis at -1. I always plot the y-intercept first, and then I use the slope. Slope is rise over run. -1 is a fraction, is -1 over 1. So I'm going to go down 1, right 1, down 1, right 1. I also could have gone up 1, left 1. And we always should actually notate the coordinates. So that's -1, 0. That's 0, -1. That is 1, -2. And that is 2, -3. Looking at that, our coordinates are going to be 0, 3 and -3, 0. I think that's it. Let's move on to the next one. Sketch the graph of each linear inequality. So now we have an inequality. So we want to isolate that. We could use the intercepts, but I'm going to convert it to slope-intercept form, just because we're going to do some other things to it. So if we isolate it, we get y is greater than or equal to -2x minus 5. We're putting it in slope-intercept form. Slope-intercept form is y equals mx plus b, where m represents the slope, b equals the intercept. Yes, this is an equation, and this is an inequality. It doesn't matter. It's still in the form. So I know that my slope is -2, and my y-intercept is -5. So I'm going to put a dot. I put a closed dot because we have, this is going to be a closed circle and a solid line. If we had greater than or less than, we'd have an open circle and a dotted line. You'll find some teachers will still put closed circles. I think that that's bad. My slope is -2. So I could go down 2 and right 1, or I can go up 2, left 1, up 2, left 1. It's equal, so we're including that border. This is the border between true and false. I don't know which side is true. This could be true, or this could be false. So I have to find a point on here and test it in this equation. Easiest point to test is 0, 0. So I'm going to take this equation, I'm going to plug in my y value in my test point is 0. My x value is also 0. So if we simplify, we get 0 is greater than or equal to -5. That is a true statement. Since this point is true, we would know that all the points on this side of the border are going to be true, and we always shade the true side. The other side would be false. You should also probably label points depending on what the teacher is expecting of you. So here we go. It's in slope-intercept form already. My slope is -3/4. My y-intercept equals 2. So I'm going to plot my y-intercept, then I'm going to use my slope. Notice this negative is in the middle. If it's in the middle, it can either be in the numerator or the denominator. It can't be in both, but there's only one negative, so you either put it in the numerator or the denominator. It doesn't matter. So I'm going to go down 3, 1, 2, 3, right 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Or I can go up 3, 1, 2, 3, left 4, 1, 2, 3, 4. That probably would have been better. I make a solid line again, and it's closed because it's an equal to. That means the border is true. All border points, all points on that line are going to be true if we plug those in. We're going to find a test point. Again, 0, 0 is going to be my easiest point. So I'm going to plug 0 in for y and plug 0 in for x. And I get 0 is greater than or equal to 2. That's false. So this time, this test point is false. So I know that all the points on this side are going to be false. I don't shade the false side. I'm always going to shade the true side. So if that test point is false, that means the other side is true. Let's work on number 7. Now we have systems. Systems want to know, these are two lines on a graph. You have x and y, and it wants to know the intersection. It can intersect at one point. It can intersect in no points. This is no solution. Or it can be the same line, and that would be all points on the line. Some schools will tell you infinitely many points. Infinitely I don't like because it doesn't tell you the location. This is one point, it's a location. No solution means there's no points, it's a location. All points on the line. That's a very specific location. So understand that's what we're doing when we use systems. There's a fair number of different ways. I'm going to use, I'm going to multiply. I'm going to use the multiplying. I'm going to multiply this by -1. We want to cancel one of the either the x variable or the y variable through addition. You could have subtracted, but I think subtraction is more complicated. So if I multiply this top equation by -1, it converts it to an equivalent equation of -5x plus 2y equals -2. All I've done is multiplied -1 times each of the 3 pieces. And then I'm just going to keep my bottom equation the same. Now I'm going to use addition. I'm going to add the columns, like terms. I have my x's, I have my y's, and then I have my constants. You notice that it's in the same format. Both equations were in the same format. They were both in standard form. It's important for you to have these two equations in identical forms. They could either be in slope-intercept form, they can be in standard form, they can be in all the constant to the left too if you want, along with the variables, but they just have to be the same. So if you have -5x and x, that gives you -4x. These cancel, hence why we are doing this. And then it equals -8. So we've canceled the variable, and that's very efficient for us. Now we're going to solve for it. We get x equals 2. So we've solved one portion of this, and then we're going to take this and plug it back into one of these two original equations. I'm going to use x minus 2y equals -6. I'm going to plug in 2 for x, and then I'm going to solve for it. Solve for the variable y. 2y equals -8 divided by -2. Y equals +4. So this is a point. It's a coordinate. I'm provided a x and y coordinate. So 2, 4. Notice number 8, we're still doing systems, but both equations are in slope-intercept form. That's fine. That really lends itself to substitution. We're going to take this equation and we're going to substitute it in. Because we know y equals this, and that same variable y equals that equation. So we know that y equals y. So let's take the y from the first one, 2x plus 2, and let's take the y value in terms of x on the second one. The nice thing is, notice, we have only one variable. So I'm going to add 1/2, always move the variables. That gives me 5 over 2x. I've converted 2 and 1/2 to mixed numbers. I'm also going to move the constants to the right, variables to the left, constants to the right, and that gives me -5. Whenever a fraction is multiplying by the variable, the way we isolate it is we multiply by the reciprocal. And that leaves me with x equals, these cancel. That's -1 times 2 is -2. And then I go back and I take either of these equations and I'm going to plug in my x value. I'll use the bottom equation. No, let's use the top equation. Top equation looks a little bit easier. Doesn't matter which one. Let's plug in -2 for x. We get y equals -4 plus 2. Y equals -2. So that point of intersection, this is a line. This is going to be some form of line. This is going to be another line. And where do they intersect? Right here. And that's what we're looking for. Systems are looking for the intersecting point between these two linear equations, these two lines. That intersection is -2, -2. Number 9. Notice that they are not in the same order. You got y by itself here, but you got y and a constant. They have to be the same. You have to manipulate this equation so they look identical. So I'm going to keep that as -2y equals, and I'm going to put the variable first, x, and then this becomes 8y equals -2x minus 24. Now, they don't cancel. You can't add them or subtract them. So, much like in the first problem, I'm going to cancel the y's. And if I multiply this top equation by 4, that now becomes -8y equals 12x minus 16. Remember to multiply all three pieces by 4. And then I'm just going to bring that second equation over. And notice my y's cancel, which is good. That would leave me with 0 equals 10x minus 40. I'm going to isolate for x. I get 40 equals 10x, divide by 10, 4 equals x. And then I'm going to take one of these equations and I'm going to plug it back in. So -2y equals -4 plus 3x. Let's plug in my 4 for x. -2y equals -4 plus 12. -2y equals 8. Divide by -2, and we get y equals -4. So my coordinate is going to be 4, -4. It's my x value and my y value. Number 10, simplify. Your answers should contain only positive exponents. I love that. All right, so when we're multiplying this, we're going to multiply, since everything is multiplying, that's 3 times n times 4 times m times n to the -4th time. So it's all multiplication across. So I'm going to look at the coefficients first. So I have 3, 4, and 2. So let's do 3 times 4 is 12, times 2 is 24. Now let's look for another common variable. N to the first, n to the -4th, n to the -1. Whenever we multiply like bases, we are going to add their exponents. That's n to the first plus n to the -4th plus n to the -1. Probably should have done m first, alphabetical order. That was bad. And let's do the m's. So we have m to the first, m to the second. So that's going to be m to the 1 plus m to the -2. In my answer, I'm going to start moving that. So +1 minus 2 gives me -1. N gives me -4. Since it says positive exponents, I have to change that. If I change the sign of the exponent, I have to change the location. It's currently in the numerator. So when I write it again, it needs to go in the denominator. I don't have to write 1. We would never write m to the first. And again, we have n to the -4. If I change the sign of the exponent to positive, I'm going to change the location. It's in the numerator. It's now going to be in the denominator, and it becomes positive exponent. I didn't do the 24 because its exponent is 1. So that stays up in the numerator. The m and the n's have to move down to the denominators. So when we have a power of a power, we know that we have to distribute it to both pieces inside. So that becomes 3 to the negative 2, x to the 2 times negative 2. When you take a power of a power, you're going to multiply their exponents. So this is 3 to the negative 2, x to the negative 4th. We can't have negative exponents. We would have to simplify that. That's going to give me 1 over 3 to the 2nd. And then this is going to go down into the denominator also and change and become a positive exponent. We get 1 over 9x to the 4th. On number 12, we have division. When we divide like bases, we're going to subtract their exponents, and that subtraction part takes place in the numerator. And that 4 doesn't have a partner, so it stays in the denominator. A to the negative 2, b to the negative 1 over 4. Since we can't have negative exponents, I have to change this sign, and it'll go in the denominator. Change this sign, and it's going to go in the denominator. So I'm left with 1 over 4a to the 2nd b. The 4 is in the denominator. Since I moved both of these numerators down, I'm left with a 1 in the numerator. Number 13, multiplying scientific notation. We're always going to take that base and we're going to multiply that. 2.8 times 6, let's do that. 2.8 times 6 gives me 16, no, let's not do it in yellow. 16.8 times, we have like bases. We're multiplying. What do we do with those exponents? We're going to add. So we get 16.8 times 10 to the negative 2. Notice scientific notation. This value has to be between 1 and 10. So I'm going to have to move that decimal point one place. That's a 10. It's a place of a 10. So we get 1.68. Since I'm representing a 10, a base 10, this is going to be 10 to the negative 1 because it's going to be a positive 10, positive 1, right? 10 to the first. 10 is equal to 10 to the first. So I need to represent that decimal place movement. And so that's going to be negative 2 plus 1, which gives me negative 1. Sorry. Now we have division. We're going to divide those bases. And when we divide those like bases, we are going to subtract their exponents. So we're going to do 8.6 divided by 5. 8.6 divided by 5 gives me 1.72 times 10 to the 4 minus 1. 1.72 times 10 to the third. This value's between 1 and 10, so we're fine. We don't have to move that decimal point anywhere. Oh. So that would be my final answer. Here we have polynomials. We're adding polynomials. If we distribute this positive 1 into it, that would just leave us with 2k squared plus 5k to the third minus 2k plus 2k squared minus 5k to the fourth minus 8k. It doesn't change any of the values inside there because a positive 1 just keeps it the same. Now we want to probably put it in descending order. Whenever we put it in standard form, it is alphabetical order first, and then if they have the same variable, then we're going to look at their coefficients. So we're going to put it in order of, exponents. We're going to put it in order of their exponents. Coefficients, that was bad. We're going to put it in order of their exponents. So my first exponent is negative 5k to the fourth plus 5k to the third plus 2k squared plus 2k squared minus 2k minus 8k. And now I'm going to combine like terms. First term doesn't have a like term, so 5k to the fourth. 5k to the third doesn't have a like term. These are like terms, so that since they are like terms, we're going to combine their coefficients. These are like terms, so we're going to combine their coefficients. And that would be your answer in standard form, descending order by exponent and variable, alphabetical order by variable. Now we're going to subtract. So notice this is subtracting, so we have to distribute this negative into the parentheses. So this gives us 4x plus 8x squared plus 2x to the fourth minus 3x squared plus 3x minus 5x to the fourth. Let's put them in descending order again. 2x to the fourth minus 5x to the fourth plus 8x squared minus 3x squared plus 4x plus 3x. These are like terms. You're going to get negative 3x to the fourth. These are like terms. You're going to get plus 5x squared. These are like terms, plus 7x. You can't combine those because they're unlike terms. Like terms have the same variable to the same exponent. We're going to multiply these. You can use FOIL, but since these are conjugates, I know that the inside, the 4k, and the outside, negative 4k, will cancel. So whenever I multiply conjugates, I know that I'm just going to multiply the firsts and the lasts. So this will give me k squared minus 16. This is a binomial square. We know that that's going to equal 3n plus 6 times 3n plus 6. We cannot distribute into there because it's adding and subtracting. We could distribute on this one. I think it was on that one. Where was that? Oh, maybe it was here. Where did we do that? We can distribute here in this problem because it's multiplication. You can distribute exponents across multiplication. You cannot distribute exponents across addition and subtraction. So we could FOIL, we could do first, outer, inner, and last. However, binomial squares is going to equal 2FL plus L squared. I don't know if you remember that, but we square the first. 3n squared gives me 9n squared. We're going to do first times last. 3n times 6 is 18n, and multiply it by 2, which gives me 32n. And then we square the last, which is 36. That's the easiest way to do it. Well, easiest if you're familiar with it. Otherwise, you could just continue with the foiling technique. This is first, outer, inner, last. That would give you the same value. If you're looking to get into honors geometry, you should be knowing those shortcuts. So here we'll just distribute. Now we'll just use traditional FOIL. 6x times x gives us 6x squared. 6x times 4 gives us 24x. Negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. We have inside and out are going to be like terms, so we have 6x squared plus 22x minus 8. Same thing with number 20. We're just going to use FOIL. 7x times 2x gives me 14x squared. 7x times negative 4 gives me 28x. Negative 8 times 2x gives me negative 16x. Negative 8 times 4 gives me positive 32. We have like terms here. 14x squared minus 44x plus 32. hard not to use your hands on the smartboard. All right, factor out the common factor. It sort of gives you an understanding that you're not going to factor a times c because it just wants the common factor. So we're looking at each of these terms. We're looking at the coefficients first, negative 35, positive 4, negative 20. So it has a common factor of 5. And since my first term is negative, I have to factor out a negative 5. And now we look at the variables. What do they have in common? Well, since this one doesn't have an x, we can't take a variable out of this. So we're just going to take that negative 5 out of it. Negative 5 divided by negative 35 gives me 7 x to the third. Negative 5 divided by positive 40 gives me negative 8x. Negative 5 divided by negative 20 gives me positive 4. And we can check and make sure. There's 2 checks. We can redistribute it, make sure that we get the starting problem. And we also want to look inside here and make sure that we don't see a common factor, that there's no variable that they have in common in here, and there's no coefficient that we can factor, no number that goes into any of those. That's always a good double check. So that would be factoring a common factor. Here, now we're going to factor. We have to recognize things. Remember, step 1 is common factor. Step 2 is special cases. I might be forgetting things because I haven't done it in a while. Number 3, I think, is A times C. And 4 is, I think 4 was FBG, factor by grouping. I think that's how we did it. And then 5 is going to be very interesting. That is going to be the Pythagorean, the quadratic formula. But we'll get to that later. We never got to that. That's this week. Common factor. There is no common factor from 9n squared and negative 25. However, it is a special case. Special case, we're looking for dead on the street, difference of squares, or bologna sandwich, binomial square. Remember, dead on the street has 3 criteria, 2 terms, subtraction, and both perfect squares. So this has 2 terms, it has subtraction, and both are perfect squares. So this is a difference of squares. I'm going to take the square root of the first, which is 3n. I'm going to take the square root of the second, which is 5. And remember, difference of squares create conjugates. That's why there's only 2 terms, because the inside and the outside cancel each other. So difference of squares is always, this is the difference of 2 perfect squares. That's why it's called difference of squares. Here, this is not a special case. Oh, excuse me, it's not difference of squares because it's not 2 terms. All difference of squares always has 2 terms, but we're going to check for binomial square. Binomial square has 4 criteria. First thing is 3 terms. Yep. Second sign positive. Yep. First and last are perfect squares. Yep. And now we take the square root of the first, square root of the second. We're going to multiply it and double it. Does it equal my middle? 3r times 1 is 3r. Double it gives me 6r. Good. And now we know that this is a binomial square, and this sign is always going to be the sign of the first. Okay. And we know that signs are the same. Both are negative. We also know that. So we get a binomial square, quantity of 3r minus 1. 24 looks like a traditional A times C. It is not a special case because it doesn't have 2 terms, so it's not difference of squares. It's not a binomial square because the last is not a perfect square, so we have to do A times C. Remember, A times C comes from this format, A and C. So the coefficient of the squared value, which is m, so A is 1, C is 2. 1 times 2 is 2. What are the factors of 2? 1 and 2. The signs are going to be the same, and they're both going to be positive. Does that equal my middle value? Yes, that equals my middle. So I'm going to break this into 4 terms. Where did I get these two values? From right here. So now I'm going to factor by grouping. I'm going to take the first two and the last two. I have a common factor of m. If I factor out an m, I get m plus 1. I'm going to factor out a 2 from the second set, and I get m plus 1. I have to make sure that these must be the same, always have to be the same. So I'm going to factor that out, and what does that leave me with? That leaves me with m plus 2. Number 25, not a binomial square, not a difference square, and not a binomial square. So I'm going to do a times c. A is 5, c is -7, that gives me -35. Factors of 35, 1 and 35, 2 no, 3 no, 4 no, 5 and 7, 6 no, and then I'm around the horn. My signs are different, and the bigger is going to get the negative. So that's going to be negative. This is going to be positive. 35 is bigger, so that's why the bigger got the negative, and the other one got the positive. That gives me -34. This gives me -2. Which one equals my middle? That equals my middle, so I'm going to change this trinomial to a 4-term. So 5n squared plus n minus 35n minus 7. Remember, this has to simplify back to that middle. I'm not changing this equation, I'm just rewriting it a little bit. All right, so let's factor by grouping now. We're going to factor out an n. We get 5n plus 1. Let's factor out a -7. First term is negative, so I have to factor out a negative, and I get 5n plus 1. Make sure that the things in the parentheses are the same. Got to make sure that they're the same. If they're not, then you made a mistake. So since they have 5n plus 1 in common, we're going to factor that out, and that leaves us with n minus 7. Here we have 9. Ooh, close. And I noticed 9 and 18. Remember, our first step is common factor. If there's a common factor amongst the three of these, I should definitely be factoring it out. 9, 18, and 51. Oh, 51. You would think that that's prime, but 5 plus 1 is 6, and 3 goes into 6, so 3 goes into 51. Really important to know your factor rules, or your divisibility rules. So I'm going to factor out a 3 from this. And I get 3b squared, 51, I don't know 51 divided by 3 by heart. That's 17 minus 6. So I'm dividing each of these by 3. All I did was factor. Now, I have this 3, 17, and -6. Yep, those are good. There's no common factor. There's no variable. It's not a special case. So I'm going to do a times c. 3 and -6 gives me -18. The factors of -18 are 1 and 18, 2 and 9, 3 and 6, 4, no, 5, no, 6. We're around the horn. My signs are different. The bigger is positive. So positive, negative, positive, negative, positive, negative. 17, 7, and 3. Which one's equal to my middle? That one is. So we have 3 times the quantity. I don't need those just yet. 3b squared plus minus b, Mr. Mac, minus b plus 18b minus 6. Remember, this has to simplify back to positive 17. Now we're going to factor by grouping. We're going to group the first two and the last two. So I'm going to factor out a b from the first two, which gives me 3b minus 1. I'm going to factor out a 6, a positive 6. My first term is positive, so I'm going to factor out a positive 6. And that gives me 3b minus 1. So they both have 3b minus 1, so I have 3 times the quantity 3b minus 1 times the quantity b plus 6. Woo, baby! Love it. That's a good one. You get that one right, you pretty much have factoring down. All right, combining like terms. We have two terms, two fractions that we have to combine. And we know with any fractions, they have to have common denominators. These do not have common denominators. So we need to find a common denominator. If I have 1/5 plus 1/7, what's the easiest way to find a common denominator? Multiply the two denominators together. So we get 5 times 7, which is 35. So what's this missing? What's this denominator missing? Excuse me, what's this denominator missing that this has? Well, it's missing a 7, so I take the 7 and multiply it by the numerator. What's this denominator missing that this has? It's a 5. So I have to take the numerator and multiply it by 5. And that's how we do it. We're going to use the same technique with this. So common denominator is going to be r plus 3, r minus 3. r plus 3, r minus 3. So let's take that first fraction, 2 over r plus 3 equals what over r plus 3, r minus 3? So again, what is this missing to get to this? We have to multiply it by r minus 3. So in order to keep it as an equivalent fraction, what we do to the denominator, we have to do to the numerator. So we get 2 times the quantity r minus 3. We look at the other fraction, 3r over r minus 3. What's this missing to that? Well, we're going to multiply it by r plus 3. So that new numerator is 3r times the quantity r plus 3. Now we have like denominator. Well, let's simplify them. Let's do that. That's probably easiest. 2r minus 6 and 3r squared plus 9r. Now we have like denominators, so let's combine their numerators. So we're going to get 2r minus 6 plus 3r squared plus 9r all over r plus 3, r minus 3. Let's put it in standard form and combine like terms. 3r squared plus 11r minus 6 all over r plus 3, r minus 3. 9, 10, 11, yep, that's good. Now we have to test and factor. We gotta, oh, I did it, sorry. Let's make sure that that's not factorable. So we have a times c, 3 times negative 6 is negative 18, 1 and 18, 2 and 9, 3 and 6. Signs are different, bigger is positive. 17, 7, and 3. None of those equal my middle, so I know that that is not factorable. So this is going to be my final answer. That's a tricky one. Common denominator. Well, here we go. We have a common denominator of 2 and 5m plus 5. If I factor that, I'm going to change that denominator. I'm going to factor out a 5 and I get m plus 1. So prime factorization is 2, prime factorization is 5 times the quantity m plus 1. We can't separate those. So do they have anything in common? No. So my LCM, nothing in common. What are the leftovers? 2, 5, and m plus 1. So my common denominator is going to be 10 times the quantity m plus 1. 10 times the quantity, wow, just trying to erase. I have to use my eraser for the first time this year. 10 times the quantity m plus 1 is going to be the common denominator. So when we have 6 over 2 equals what over 10 times m plus 1, what did I multiply 2 to get that? Well, I multiplied it by 5 times the quantity m plus 1. So I have to multiply this by 5 times the quantity m plus 1. So I have 6 times 5 times m plus 1. What's this missing that this has? Well, that's a 2. So I'm going to multiply 2 times whatever is left in the numerator. So that is 30. So we get 30m plus 30. We're just distributing it. Minus 6 over 10 times the quantity m plus 1. Let's simplify. We get 30m plus 24 over 10 times the quantity m plus 1. Remember, let's try to factor. This is only 2 terms. And m is to the, well, let's look first, common factor. Yeah, there's a common factor there. So what can we take out? We can take out a 6. If we take out a 6, we get 5m plus 4 over 10 times the quantity m plus 1. So we can simplify these. What goes into 6 and 10? A 2. So that becomes 3, that becomes 5. You cannot cancel these m's because they're being added and subtracted, and they're in parentheses. So my final answer is 3 times the quantity 5m plus 4 over 5 times the quantity m plus 1. That is the best high school answer. All right, 29. Now we're multiplying. Multiplying is easier, but we want to factor. We want to look and see, can we factor that? That's already factored. So before we start cross-canceling anything or multiplying anything, we want to factor, see if we can simplify. So we get 10x squared over 4. Let's factor out that 4. You get x minus 9 over x minus 9. Nice. We're going to cross-cancel. We can cancel that because it's being multiplied. We're canceling the x and the negative 9. X minus 9 as a whole piece. Let's cancel the 4's. When we cancel those get replaced by 1's. So what are we left with? We're just left with 10x squared. That's nice. This one we have division. We can't do anything. We can factor. So we can factor out an 8. You get n plus 1. And the 8, we're going to convert the division to multiplication by flipping. So 3 goes in the numerator. And now we're going to look and see if we can factor that. When you get really good, you know what that is factored, our a times c. We can find, we get good and we can do those basic ones. And we can maybe do mental math with that. So now we're going to look to cross cancel. Can we cross cancel? 8's will cancel. N plus 1 will cancel. And we're left with, my final answer is 3 over n minus 8. Love multiplication and division. Now we have the same idea, but it's an equation. So instead of finding common denominators and subtracting these two, let's just get rid of the denominators. The easiest way is to cancel out all the denominators by finding the LCM of those denominators. So you have x squared, you have 4x squared, and you have 2x. Prime factorization. Now, LCM, what do they have in common? Well, let's look. They all have, wasn't good. Why didn't it change? They all have a single x in common. 2 of them have an x, 2 of them have a 2, and then my leftover is 2. So my LCM is going to be 2 times x, or 4x squared. So if I multiply everything times 4x squared, that should get rid of all these denominators. I'm going to multiply each of these by 4x squared. So the x squared and the x squared cancel when I multiply it by there, and that leaves me with 4. Then I'm going to multiply that 4x squared times that, and notice they're identical, so it leaves me with a 1. And then I'm going to multiply it by that. The 2 cancels with that. The x cancels with one of those. 2 times 2x gives me negative 2x. So we just changed this equation. It's equivalent. It's a more efficient I just got rid of all the denominators. And now I can just solve it like any regular problem. So I'm going to isolate for x. I get 3 equals negative 2x, divide by negative 2, x equals 3 over negative 2, or negative 3 halves. Now it says check for extraneous solutions. Those are solutions that when we plug them back in, makes the denominator 0. So if I plug in negative 3 halves into this, does that make 0? No. If I multiplied that, if I plugged negative 3 halves in for x squared, does that make 0? No. If I plug it in to this x, does it make 0? No, it makes negative 3. So as long as none of the solutions make 0 in the denominator in your original problem, that'll have your solution. So that's your answer. There's only one answer for this one. Let's check this one. So the denominators, x minus 2, we have x, and then we have x squared minus 2x. I'm going to factor that to make it that. So prime factorization is x minus 2. You can't separate those. Those are tied together. Prime factorization of that is x, and the prime factorization is going to be, what do they have in common? They have an x minus 2 in common. They have an x in common. So my LCM is going to be x times the quantity x minus 2. And I'm going to multiply everything times my LCM. I'm going to distribute that to that, and distribute it to that, and to that. So if I distribute it here, the x minus 2's cancel, and you're left with the numerator times what's left over, an x. If I distribute it to this, the x's cancel this time, and you're left with 1 times x minus 2, which would give me x minus 2. If I distribute it to this, notice, remember, this used to be x squared minus 2x. So those are going to cancel out completely, and we're left with 3x plus 9. Let's simplify the right side before we start moving things. You're left with x equals, these are like terms, they're on the same side of the equation. These are like terms, they're on the same side of the equation. And now we're going to move the variables. After I simplify, I'm always going to move the variable first. Divide by negative 3, and I get x equals negative 7/3. Doesn't seem right. So let's check and make sure I did this correctly. I think I did. That's correct. X minus 2 is correct. 7, 8, 9, 4x. Yep. All right. So if I plug it in back into each of the denominators, do any of those become 0? No. So there are no exclusions for that, and my only solution is negative 7/3. Let's look at 33. We are simplifying. This is a square root, so I'm going to separate them into their own houses. Remember, I'm going to break it in. I'm looking for perfect squares. So rad 4 is a perfect square. So rad 4 becomes 2. Rad 2 stays as rad 2. The square root of p squared becomes p. And rad p stays rad p. Whatever is outside of the house, negative 6, 2, and p, we're going to combine those to make negative 12p. Whatever is inside the house will be recombined under the same house, 6p. So negative 12p rad 2p. Love radicals. Now we're going to solve for the variable. Much like absolute values, we're going to isolate the radical first. So we're going to add 4 to both sides. You get 8 equals rad 3x plus 58. What gets rid of a radical? What gets rid of a square root is a square, so we're going to square both sides. You get 64 equals 3x plus 58. And now we're going to subtract 58. And that gives me 6 equals 3x divided by 3. And you get 2 equals x. We could go back and, oh, I think I moved it without the board shifting. Now we can go and test it. If we plug in 2, 3 times 2 is 6. 6 plus 58 gives me 64. The square root of 64 is 8. 8 minus 4 equals 4. So that worked nicely. Find the slope of the line. Now we move back towards linear stuff. We know that slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, y sub, so we have x sub 1, y sub 1, x sub 2, y sub 2. The sub means the point. That's the x value in the first point, y value in the first point, x value in the second point, y value in the second point. So we have y sub 2, which is negative 19 minus y sub 1, which is 0. We have x sub 2, which is 19 minus my x sub 1, which is negative 12. That leaves me with negative 19. 19 plus 12 gives me 31. And so that would be my slope. That cannot be simplified. Write in standard form. So standard form is ax plus by equals c. There are no values that you can plug in. What you really have to do is find it in slope-intercept form or point-slope form, and then convert it to standard form. So I'm going to pick slope-intercept form because I can see the intercept and I can find out what the slope is real easy. So I'm going to make it into slope-intercept form, plugging in for the slope and the y-intercept. So I already see that the y-intercept is 2, and my slope is up 2, left 1, 2, 3, 4. So up 2, left 4, rise over run. So up is positive 2, left is negative 4. So that gives me negative 1/2. Negative 1/2 x. That is in slope-intercept form, but it asks for standard form. Standard form has x and y on the left side and the constant on the right. So I have to get the x and the y on the left side. So I'm going to add 1/2 x. That leaves me with 1/2 x plus y equals 2. And most people would stop there. However, when in standard form, a, b, and c must be integers. That's positive or negative whole numbers. And a must be positive. So a is positive, but a is a fraction. So I'm going to multiply this by 2. I'm going to multiply everything by 2, and that gets rid of that fraction in my first one. So I'm left with x plus 2y equals 4. It's in standard form. A, b, and c are integers, and a is positive. Write the slope-intercept form of the equation in each line. This is nice. It's super easy. My intercept is 1. I'm going to find 2 points, and then I'm going to see what the slope is. I'm up 1, and 1, 2, 3, 4, 5. Right 5, rise over run. I rose 1. I went right 5. Up is positive, right is positive, so my slope is 1/5. So my equation is y equals mx plus b, plugging in for the slope and the intercept. My slope is 1/5. My intercept is 1. Right, standard form of the equation. So I was given slope-intercept form. So I'm going to plug in the slope. I'm going to plug in the y-intercept. And now I'm going to put it in standard form. I'm going to add 2x to both sides to get the x and y on the same side. Is my a, b, are my a, b, and c integers? Yes. Is a positive? Yes. Then that is in standard form. Write the slope-intercept form of the equation. This is real nice and easy because they gave me the slope and the y-intercept. So all I'm doing is plugging in for m and b. Slope is positive 2. intercept is positive 4. Wish we could get lots of those easy problems. Number 40, write in point slope form. Well, there's two ways of doing this. The y-intercept is a point. Remember, it's a location on the y-axis. So technically, when you have an intercept of y-intercept of -4, your point is 0, -4. Point slope form is y minus y sub 1 equals m times the quantity x minus x sub 1. Almost forgot that. Where x sub 1 and y sub 1 are the x and y values of a point. So we substitute it in. What's my y value? Is -4. What's my slope? Well, it tells me my slope is 5. What's my x value? 0. So we would rewrite it as y plus 4 times the equals 5 times the quantity x minus 0. You want to leave it like this. You want to simplify those double signs, and you want a value times a quantity in that, because you want to be able to pull out the point later on. Write the standard form of the equation of each line. Standard form, that means I have to get x and y on both sides, so I'm going to move that x over. My a, b, and c have to be positive and an integer. My a is negative and a fraction, so I'm going to multiply it by -3. The negative makes my a positive, and the 3 cancels the 3 in the denominator. So that leaves me with 2x. I'm going to distribute it to here, -3y, and don't forget the c value. So only a has to be positive. B and C can be negative. They just have to be integers. All right, 42. I think we're still getting this in standard form. Let's simplify. So we distribute the -2 to both of those. And now let's move the x over and get that constant back over here. So it leaves me with 2x plus y equals 5. 43, slope-intercept form. Slope-intercept is isolating y, so we have to get y by itself. Let's simplify first. We have y plus 5 equals 9/4 x plus 9. 9/4 times 4, there's 4 in the numerator, cancels with the 4 in the denominator. And now let's move the constant over. Let's isolate y by itself. And we get that. Write the standard form of the equation. So that's just getting x and y on the same side. -3x minus 3y equals -6. It's a nice tricky one. We will multiply everything by -1 because my a has to be positive. If I multiply everything by -1, it changes the sign. So I get 3x plus 3y equals 6. Write the slope-intercept form of the equation of the line. Slope-intercept form, remember, is y by itself. I'm just going to rewrite this. I'm just going to flip-flop these left sides. I'm going to switch the equals just around, and then I'm going to divide everything by -3. And that gives me y equals -1/3 x minus 1. You also could have written y equals -x over 3 minus 1. You also could have written y equals x over -3 minus 1. All three answers are correct and equivalent. Write the standard form of the equation of the line through standard form. All right, so let's use point slope because we're given a point and the slope. So y minus y sub 1 equals m times the quantity x minus x sub 1. Y minus my y sub 1 point is -5. My slope is 10. X minus my x sub 1, which is -1. That gives me y plus 5 equals 10 times the quantity x plus 1. Let's distribute. Y plus 5 equals 10x plus 10. And now, let's rewrite that. Can I move it? Yes, nice. Oh, not even moving the screen anymore. Let's move my x's to one side and my constants to the other. It's negative 10x plus y equals 5. And now let's multiply everything times negative 1 because my a is negative and I got to get it positive. 10x minus y minus 5. That's really good. And I need a sip of water because we are doing some major talking. Oh, now I tried to move and it didn't work. Of course. Write the slope-intercept form of the equation through the given. So slope-intercept. So again, I'm going to use point slope because I'm given a point and slope minus my y value, my slope minus my x value. Y minus 2 equals 3 times the quantity x plus 1. Y minus 2 equals 3x plus 3. Let's add 2 to both sides because we're isolating y. Y equals 3x plus 5 would be in slope-intercept form. Write the point-slope form of the equation of the line through the given point with the given slope. Point-slope form. I got point, slope. That's nice and easy. All right, so we have y minus my y value, my slope times minus my x value. So we get y plus 1 equals negative 5/3 times the quantity x minus 3. Very nice. Real easy when they give you the point and slope. Find the value of c that completes the square. Remember, completing the square. Completing the square creates a binomial square. And remember, binomial squares would be this. They derive from this. So I know that this needs to be a perfect square. So what I do is I'm going to divide that and square it. Divide by 2, and then square it. So that's 11p, and then I'm going to square it. Not square it. I'm going to divide by 2 and square. So that's 121. P squared plus 22p plus 121. That would be completing the square because this would be now a binomial square. Okay? And whenever we complete the square, the coefficient of your x squared or your first term must be 1. That is the only way you can divide by 2 and square because that will mean that the coefficient of p is always coming from my constant. So very important. Not a lot of teachers teach you that and remind you that a always has to be 1 when you're completing the square. So solve each equation completing the square, number 50. So first thing we need to do is we need to get this value away. We need this constant value gone. It needs to be on the other side. So it looks like that practice problem we did in 49. So I'm going to subtract 9. That gives me x squared minus 8x equals negative 12. Now, what does this value have to be in order to make this left side a binomial square? Well, again, we divide by 2 and take that value and square it. Negative 8 divided by 2 is negative 4. Negative 4 squared gives me positive 16. Whoa. Positive 16. Now, look, I just added 16 to this left side. So in order to keep this equation correct, I also have to add 16 to the left side. So this left side factors to x minus 4 quantity squared. That's what the binomial square would factor to, equals 4. Negative 12 plus 16 gives me 4. Now, I take that equation and I can solve for it. I want to isolate the variable x. It's being squared, so I need to take the square root. The square root and the square cancel each other. I'm left with x minus 4. Whenever I take the square root of a variable being squared, I have to do plus or minus. The square root of 4 is 2. And now let's isolate the variable x. So I'm going to add 4 to both sides. And I get x equals 4 plus or minus 2. What does that mean, Mr. Mack? Well, that means 4 plus 2 or 4 minus 2. 4 plus 2 is 6. 4 minus 2 is 2. So my solutions are 2 and 6. That would be solving for that quadratic equation. That equation that is a quadratic by completing the square. It's a nice, fun way. That's one of a number of ways of solving for quadratic. So in this problem, instead of completing the square, because if you divide by 2 and square it, you're going to get 49 over 4, and that's just a crazy, ugly number. So what we can do is we can use the quadratic formula. Quadratic formula tells me the opposite of b plus or minus square root of b squared minus 4ac all over 2a. And we're getting a, b, and c because we get this. Remember, quadratic equations have that. So we have to set this equal to 0 first. So we have to move that constant to the left to get v squared plus 7v plus 12 equals 0. That means a is equal to 1, b is equal to 7, and c is equal to 12. A doesn't always have to be 1 here. A has to be 1 when you're completing the square. When you use the quadratic formula, a is going to be all different types of values. So a is 1, b is 7, c is 12. Let's use the quadratic formula. So the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Negative 7 plus or minus 49 minus 48 all over 2. Negative 7 plus or minus square root of 1 over 2. Negative 7 plus or minus 1 over 2. Square root of 1 is 1. And we get negative 7 plus 1 over 2 and negative 7 minus 1 over 2. That gives me negative 6 over 2, which is negative 3. This gives me negative 8 over 2, which is negative 4. So my solutions are negative 4, negative 3. I always put them in numeric order. And that would be your answer using the quadratic formula. You see, when we completed the square, you still got that plus or minus. You would still, if you use this equation, opposite of b plus or minus square root of b squared minus 4ac all over 2a, for number 50, if you move this negative 3 over, you still would have gotten this answer. You still would have gotten 2, 6. So this lends itself to completing the square. This lends itself to the quadratic formula. Find the discriminant of each quadratic equation, then state the number of types of solutions. Remember, quadratic equations create parabolas, and parabolas look like that. So when we find these solutions, they're actually called the zeros, and they're called the zeros because notice we set this equation equal to 0, and this is really equals y. So a, x squared plus bx plus c equals y. X and y are it's a point. It's a point. And remember, we're creating a parabola, so you have lots of x and y points. And notice what we put in for y. We put 0 in for y. And when we put 0 in for y, if we look at when y is equal to 0, when y is equal to 0, guess where we are? We're on the x-intercept on the x-axis. So we can get situations where you get this or you get this. So there are 3 different ways. There's 6 different ways. It can go in the other direction also. But you have intercepts. You have one x-intercept. You have 2 x-intercepts. And you have no x-intercepts. We saw in this case, how many x-intercepts did we have for number 50? We had 2 and 6. Because we plugged in 0 for y. We set it equal. So I know 2 points of this equation. We got 2 x-intercepts. So we want to know, going forward, find the discriminant. Well, the discriminant is determined by a portion of the quadratic formula. Remember, the quadratic formula looks like this. And what determines it is this piece right here, because we're taking the square root of this. And if we take a square root, if this b squared minus 4ac is positive, then we can find 2 solutions. Because remember, it's going to be plus or minus. So you get 2 solutions. If my square root of 0, well, square root of 0 is 0, so we're going to get plus or minus 0. So it's going to be whatever that value is plus 0, this value minus 0. And so that's going to be the same value. If you have 7 plus 0 and 7 minus 0, so we only get one solution when b squared minus 4ac is equal to 0. And then when that is a negative number, we're going to get no solution because we can't take the square root of a negative number. So this is going to be one solution. That's when our b squared minus 4ac is equal to 0. No solution is going to be when b squared minus 4ac is less than 0, meaning a negative number. And when b squared minus 4ac is greater than 0, that means it's a positive whenever we're going to get 2 values, 2 solutions. So when it says find the discriminant, we have to use b squared minus 4ac. So first thing we have to do is set it equal to 0. And I'm not 100% certain on this, but I'm almost certain that a has to be positive. So let's multiply everything by -1. That gives me 10n squared minus 3n plus 3 equals 0. I like that better. I'm pretty sure that that's correct. So my a is 10, my b is -3, my c is positive 3. So let's plug it into b squared minus 4ac. So b squared is -3 squared minus 4 times a times c. So that's going to give me 9 minus 120. Yeah, minus 120, which gives me -111. So since my discriminant is negative, I know that I'm going to have no solution. So how many solutions? No solutions, 0 solutions. And what that really means is that this parabola will not cross the x-axis. Let's look at Desmos real quick. Let's plug that equation in, just for kicks and giggles. What do we know about the equation first? Since a is negative, we know that it's going to be an upside down parabola. Now, Desmos. Let's plug that crazy equation in. -10n squared plus 3n minus 1 equals -2. Uh-oh. What's the matter? Did I not do that right? Minus 1 equals -2. No, let's move it over. Oh, I have no y. Sorry. Let's -2. So let's move it over. That becomes +1. And let's equal y. Sorry, we need a variable. And let's make that x and x. Oh, darn it. All right, so I know I made a mistake. I made a mistake because there are two x-intercepts, that one and that one. So I made a boo-boo. Let's see. Well, let's not multiply everything by -1. Let's see what happens if I... oh, I see where I made my mistake. Sorry. Has nothing to do with that. It has to do with, that should have been +2. +2 makes +1. And then that becomes -1. And then this becomes -1. And this doesn't become, that ends up being positive 40. And then my discriminant becomes +49. And now I know that there are two solutions. Always good to check your work. Woo! All right, almost done. Last problem. Oh, I think this is the last one. Oh, two more. Holy moly, Mr. Max got a lot more to go. All right, so let's add 3. Let's make sure we get this one right. -2x² plus 8x minus, let's do our math correctly, 8 equals 0. Let's have a be positive, so we're going to multiply everything by -1. Let's write my b² minus 4ac. b is -8. A is 2. C is 8. So we get 64 minus, what is 4 times 32? 32 times 64, which gives me 0. So I know that I only have one solution. I know that it's going to be one solution. Shall we check? Yeah, let's check it. Let's be consistent. So we know, since there's one solution, we know that it's going to dot right on the x-intercept. So let's take this equation and let's do -2x² plus 8x, and then we had, what do we have, minus 8 equals y. And if we look at it, we see that it only has one intercept, dots right on it. We knew it was upside down because a was negative, so yes. All right, we're getting it now, baby. 54. Right, hopefully we're still doing it. Are we graphing these? No, yeah, so we're still finding the discriminant. So we're going to subtract 8. We get -3x² plus 5x minus 11 equals 0. We're going to multiply by -1. We get 3x² minus 5x plus 11 equals 0. A equals 3, B equals -5, y. C equals 11, b² minus 4ac, b is -5, quantity squared minus 4 times 3 times 11, 25 minus 12, which is 12 squared is 132, so it gives us -107, which means there's going to be no solutions or no x-intercepts. And just to be consistent, to see, we know that it's going to be upside down. Oh, that was weird. Oh, sorry. That had to move. So the equation is -3x² plus 5x minus 11 should have no intercepts. Yes, does not cross the x-axis. Good. All right. And last, we still more. All right. So it's in standard form. Let's graph that parabola. The parabola. Remember, when graphing the parabola, it's in standard form, so we're going to find the axis of symmetry. Is opposite of b over 2a. So opposite of negative 8 over 2 times 1, which gives me 8 over 2, which is 4. My axis of symmetry is here. My vertex also lies on the axis of symmetry, so I'm going to take this value, I'm going to plug it in for x, and that'll give me my y coordinate. So my point for my vertex is my x value and my y value. So 4, negative 1. So there's my axis of symmetry. I know that my y-intercept is 15. Way the heck up here, 0, 15. And since it's 4 away, I know that its mirror point is going to be 4 away, or 8, 15. And now I need to find a fourth and fifth point. I have 3 points, so I'm going to pick an x. What's a nice value? Probably 2. So I'm going to plug in 2 for x. So I get 2 squared minus 8 times 2 plus 15, which gives me 4 minus 16 plus 15, which gives me 4 minus 1, which is 3. So when I plugged in 2 for x, I got 3 for y, 2, 3. This is 2 away from the axis of symmetry, so I'm going to go 2 away on the other side, the mirror point. And I have my coordinates, 2, 3. This ends up being 6, 3. And I've labeled them, and that's a really good parabola. This is in vertex form, so I know that it's going to be the opposite of this value for my x and my y. So I know my vertex is going to be negative 2, 1. And my axis of symmetry is going to lie on negative 2, on that x value. So I have I know that a is negative, so I know my graph is going to go upside down. And now I'm going to pick a point. This is not the y-intercept. Understand that that's not the y-intercept. If I want to find the y-intercept, I'm going to plug in 0 for x. So I'm going to take this equation, and to find the x-intercept, I'm going to plug in 0 for x. And so I'm going to square first before I deal with that negative. So 2 squared is 4, and I get negative 3. So when I plugged in 0, I got negative 3. 0, negative 3, that is 1, 2 away. So I go 2 away in the other direction for its mirror point. And then I have to find one more value, because I should have 5 points. So I'm going to plug in negative 1 into this equation, So if I plug in negative 1 plus 2, quantity squared plus 1. Negative 1 plus 2 is 1. 1 squared is 1. So my y value is 0. When I plug in negative 1, I get 0. Negative 1, 0. And then its mirror point is going to be 1 away from the axis of symmetry. And those just happen to be the x-intercepts. I think that's it. Let's see. Yep. And here are the answers. Please check and make sure. I can absolutely make mistakes. You saw that one place I made a mistake. But hopefully there aren't too many. And Mr. Matt got 100 on his test. It's a lot of information. So good luck. That was an extremely long video. Hopefully YouTube will allow it. Have a great time. Good luck with your assessments. Talk to you.